Hello everyone, I'm back with another video, and today we'll be talking about the differentiation of this function y is equal to x to the power x to the power x to the power x. So let's see how we find the derivative of this function. So to start off, let's just write this function over here and let's apply logarithm on both the sides. So, or ln y x to the power x to the power x ln x. So we just use the property of log over here. This is the property that we use. So this power moves forward and it can also be expressed like this. So that's what we did here. Let's rub it up, and now let's apply logarithm once again. So we have double power over here. So to get rid of this, let's apply logarithm. Let's write this once again, x to the power x to the power x ln x. So now something like this. And there is another property of log. So whenever we see something like this can be written as this. So we're going to apply this property over here as well. So let's move on. Is equal to ln x to the power x to the power x plus ln x. And now let's use the property of log where we bring this power forward. Yes, now let's differentiate both the sides with respect to x. This and then this one. So now let's apply chain rule on both the sides. So ln y, this will be with respect to ln y with respect to y, and y with respect to x. Now the right hand side. So let's apply the product rule over here. Firstly, the product rule. So x to the power x comes forward, x plus and for this one, let's go over here and addition sign. With respect to ln x, and that with respect to x again. So now it's just about differentiating. So that becomes 1 upon ln y, and ln y with respect to y becomes 1 upon y, dy upon dx as it is. And then x to the power x as it is. Ln x with respect to x becomes 1 upon x, and ln x as it is. And for the differentiation, this one, I've already made a video about this, so we can just replace the value of this directly over here. But if you want to know how to solve this one, I recommend you to watch my another video where I have covered about this. So we've gotten the answer to be let's put this in a curly bracket, plus ln x to the power x to the power x. So now addition sign and the differentiation of this one. Let's write it below 1 upon ln x times 1 upon x. So let's multiply both the sides by y ln y so that we can get rid of this from the left hand side. Y ln y times y ln y times dy upon dx. Gone. And we can write this as this as it is, and these things as they are, and we can write them together. And of course, multiply this whole by y ln y. So this whole gets multiplied by this, and now dy upon dx is equal to, we can add the powers over here, minus 1 plus, let's multiply this with this and this, plus ln x times ln x to the power x to the power x plus 1 upon x ln x. Let's put this inside a big bracket, and let's replace the value of y and ln y. So the value of y is x to the power x to the power x to the power x. So let's replace the value over here, x to the power x to the power x to the power x times ln x to the power x to the power x to the power x. So now we can, if we want to, we can multiply this with this, or if we want to leave it as it is, it's perfectly fine. So I think it's better if we just leave it in the form as it is, or let's write this in the front. That would make more sense. So therefore dy by dx is equal to x to the power x to the power x to the power x ln x to the power x to the power x to the power x, big bracket, x to the power x minus 1 plus, or let's write this in the power side, so it's going to be x to the power x to the power x plus ln x times ln x to the power x to the power x. We can take these common and do all sorts of things, but let's not do that. 1 upon x ln x, and this is the final answer to this question. So I hope you enjoyed this video, learned about the derivative of this function, and hope to see you in another video. Thank you.